Deep beneath miles of freezing Antarctic ice, engineers design a hidden underground metropolis. Brutal -80-degree temperatures and shifting ice sheets threaten surface structures. A self-sustaining subterranean metropolis will protect human life from extreme polar hazards. Advanced ice core analysis maps subglacial bedrock and ice movement dynamics. Heavy polar transport fleets mobilize specialized construction machinery across vast ice shelves. Polar cargo vessels deliver modular engineering units to remote coastal entry points. Thermal melting drills carve initial vertical access shafts down through compacted snow. Autonomous robotic cutters carve expansive subterranean chambers directly out of glacial ice. Thermal smoothing heads fuse glacial ice into polished, load-bearing load vaults. Modular titanium support ribs reinforce expansive underground cavities against ice creep. Cylindrical habitat modules are lowered into place to form pressurized living quarters. Expandable multi-layer composite domes deploy to create massive, pressurized subterranean spaces. High-performance aerogel insulation protects interior modules from freezing glacial contact. Interconnected transit tunnels link research sectors, power plants, and residential hubs. Compact nuclear micro-reactors provide uninterrupted baseload power through dark polar winters. Superconducting transmission lines distribute high-voltage power efficiently across underground networks. Advanced heat exchangers utilize surrounding glacial ice as a natural cold thermal sink. Automated vertical farming modules produce fresh food crops to sustain polar science crews. Full-spectrum artificial lighting accelerates photosynthesis inside climate-controlled biodomes. Closed-loop life support systems recycle breathing air and moisture with absolute efficiency. Advanced centrifugal recycling recovers every single drop of moisture within the subterranean base. Central command stations monitor internal habitat pressure, power grids, and weather safety. Fiber optic sensor networks monitor real-time ice deformation and structural load shifts. Heavy titanium airlock vestibules provide secure multi-stage pressure and thermal separation. Electric polar exploration rovers deploy across ice sheets for scientific surface data collection. Subsurface thermal coring drills extract ancient paleoclimatic ice samples from deep strata. Specialized, sterile hot water drills penetrate subglacial lakes without biological contamination. High-speed magnetic levitation cargo tracks transport equipment between distant underground sectors. Deep space laser communication arrays transmit massive scientific datasets instantly back to Earth. Phased array meteorological towers monitor polar vortex dynamics and atmospheric changes. Subsurface seismic observation vaults record global tectonic activity without surface noise. Massive underground neutrino detectors capture elusive cosmic particles shielded by ice. On-site laboratories process pristine polar atmospheric samples inside sterile cleanrooms. High-capacity air intake towers filter and temper freezing polar winds before circulation. Autonomous robotic maintenance teams perform continuous structural repairs across utility conduits. Simulated circadian lighting systems support psychological well-being during long polar nights. Advanced hydroponic automation delivers continuous fresh yields with minimal water waste. State-of-the-art subterranean refuge pods guarantee complete safety during severe blizzards. Expanding research sectors require synchronized excavation across multiple ice sheet zones. Subsurface seismic observation vaults record global tectonic activity without surface noise. Cryogenic sample vaults store vital biological and atmospheric specimens indefinitely. Expanding research sectors require synchronized excavation across multiple ice sheet zones. Surface grooming vehicles maintain safe transit corridors across shifting snowfields. Rigid, non-destructive testing certifies structural resilience against extreme sub-zero fatigue. Surface wind and solar arrays supplement nuclear power grids during optimal polar weather. Hydraulic dampening arrays protect habitat structures against sudden glacial shifts. Autonomous robotic maintenance teams perform continuous structural repairs across utility conduits. Acoustic emission monitoring algorithms predict glacial movement long before stress occurs. BM Digital Twin technology coordinates every phase of subterranean metropolis expansion. State-of-the-art safety refuges guarantee complete protection for underground science crews. Electric rail transit networks move personnel and heavy replacement modules swiftly underground. Surplus thermal energy directly heats research quarters and operational base facilities. Precision chemical injection systems prevent ice melting and reinforce subterranean walls. Automated robotic maintenance units perform diagnostic checks without exposing human specimens. Section-by-section alignment milestones marked steady progress toward total facility integration. The underground Antarctic research metropolis stands fully operational and secure. Engineering teams celebrate the historic completion of humanity's ultimate polar metropolis. Antarctica's subterranean research metropolis stands as a monumental triumph of modern engineering. Expanding network sectors connect isolated science outposts into a unified underground city. High-speed optical laser links maintain instantaneous data transfer across deep ice vaults. Automated water purification systems convert sub-glacial meltwater into crystal-clear utility supplies. Closed-loop organic recycling bioreactors convert waste into essential agricultural nutrients. Autonomous clearing rovers keep polar landing strips clear for emergency cargo flights. High-sensitivity seismic nodes record microfractures in deep Antarctic bedrock continuously. Specialized medical research wards study extreme environment adaptation and isolation physiology. Advanced biometric security protocols safeguard classified subterranean research laboratories. Engineered thermal expansion joints protect rigid structures from relentless ice sheet movement. Automated coolant regulation valves maintain stable sub-zero temperatures around vaults. Long-term monitoring reports confirm zero negative impact on local ecosystems. High-speed electric transit links connect underground hubs seamlessly to surface facilities. Hybrid renewable energy arrays supplement nuclear reactors during peak operational loads. Antarctica's subterranean research metropolis stands as a masterpiece of extreme engineering. Global scientific cooperation unlocks the secrets locked beneath the polar ice sheet. Building a research metropolis beneath the ice sheet
secures humanity's scientific future.